All right, so number one, I have a base raised to an exponent, and there's like nothing on the outside. There's nothing added, subtracted, multiplied, divided, nothing going on the outside. So I actually can, right off the bat, I can turn this into logarithmic form. So whatever the base on my exponential is, needs to be the base on my logarithm. Okay, so this is a base of 7 on my exponential. I need a base of 7 on my logarithm. All right, log base 7 of something, it's got to be of whatever's on the other side. This is my 15 is the argument here. Log base 7 of 15 equals my exponent. The whole reason we used logarithms is to solve for the exponent. That's like the whole point. So this equals my exponent 9x. And then I'm just going to divide by 9 on both sides. And we solved for x. Log base 7 of 15 all over 9. All right, now, sometimes online, they don't want you to round, they want the exact answer, and then this would be my exact answer. And then sometimes they want you to round, which means you had to get like the decimal form. All right, small problem with this though, I think most of your calculators don't have like a log base 7. I think most of the calculators have a common log, like a log base 10, or a natural log, like a log base E, but most of the calculators don't have like a log base 7. So I'm gonna have to do the change of base formula. And you can choose whichever one you want to change it to. So like Jacob, would you prefer the common log or the natural log? For number one, it doesn't even matter because you have a common log in your calculator and you have a natural log in the calculator. They'll both give you the same answer, it doesn't matter. You just have to pick one. Common log, okay. So what I'm gonna do then for my common log, it's gonna be a common log divided by another common log. So my hint in my head, this is how I look at it. Like this 7, the base is written like smaller, right? A little lower. So I usually put that in the denominator. That's kind of my reminder. That 7 goes in the denominator. The 15 is written like bigger, like a little higher. That's going to be in the numerator. So log of 15 over log of 7. I haven't done anything with the 9 yet though. So Jacob, where does that 9 go? Oh, okay, under, so in the denominator like this?
No, like you put the log 15 and log 7 in parentheses, and you put that all over.
Oh, so that whole thing is all divided by 9? Okay, so they're actually, so you guys, I think were telling me pretty much the same thing, just in a different way. So like that whole thing is divided by 9. That is true. And I think I also heard that you could treat it as multiplied by 1/9, which is the same thing. Dividing by 9 is the same thing as multiplying by 1/9, which also means I could also, if I multiply this fraction straight across, this also is going to be putting a 9 in the denominator with my log of 7. So that's like 3 different ways to do the same thing. Either way, I'm just going to enter this in my calculator to get the decimal form. Like I said, sometimes they want an exact answer. Sometimes they want a rounded answer. So if they want this rounded answer, I'm going to go log of 15 divided by, and then in parentheses, I got to divide by this whole 9 log 7, like that whole package deal in the denominator. So I put parentheses 9 log 7. All right, so here is, if I'm going to the nearest hundredth, 2 decimals, I'm going to go with a 0.15. All right. So let's pay attention to our instructions. If they want the exact answer, I'm going to go with the one in black. If they want the rounded answer, I think I would put it in my calculator for this one in blue. Okay, any questions? No? All right, let's go to number 2 then. So Evan, what do I have to do on number 2? I think there's like a couple extra
First,
steps.
you gotta subtract the 12.
Sorry, hang on just a second. I meant Evan T. Sorry, I forget I have 2 Evans. All right, so Evan T, I think you're sitting in front of me here. What do I have to start with?
So in terms of
You're good.
This one's a bit longer than the other one.
It totally is longer than the other one. So I want to get it to where this problem number one started. It started with some base to some exponent, and there was like nothing outside of that. So in this case, like E is the base.
Don't you use natural logs for this one?
I will, you're right. Eventually I will have to use a natural log, but first, so that stuff I circled, the base to the exponent.
You want to get that?
Yeah, I want that by itself. So how do I get rid of the other, the -2 and the 12? How do I get rid of that stuff?
Would it be sure that you either, in this case, would it be addition or would it be addition? Like, am I thinking of the wrong? Oh,
So-
wouldn't you distribute it to the other side?
I do need to move it over to the other side. Does that mean I am adding the 12, subtracting the 12, multiplying by 12, dividing? What am I doing with that 12?
Probably subtracting it.
Totally, yeah. The opposite of addition is subtraction. So I subtract 12 on both sides, you got it? And I'm still trying to get this e to the x minus 6 by itself. So how do I get rid of that -2?
I feel like you would divide it.
Nice, it is currently multiplied, so you do the opposite, you divide by -2 on both sides. Kayleen, there is one. I'll talk to you about that in a sec. All right, so now we got to what we're going for. We wanted this base raised to the exponent. We wanted that stuff by itself. And then we can kind of pick it up where we did on number one. I'm going to write it as a logarithm. All right. So let's see here, Jack W. What's my base on the exponential? Nice, it's a base of E. So what does it look like if I have a log base E? Jack, do you remember what special case that was? Because usually we don't write log base E. This is one of our special ones. It's one of the ones that you see on your calculator. Do you remember which one it is? Totally, Jack. Yeah, ln, your natural log. So instead of log base E of 2, I'm going to do natural log of 2. All right, and then the whole point of a logarithm, every time, it's supposed to equal whatever the exponent was. In our case, the exponent was x minus 6. So this should all equal the x minus 6. All right. So I need to solve for x here. It looks like I just have to get rid of that -6 and add 6 on both sides. So, okay, Wilson, I'm going to come to you then. Wilson, if I do natural log of 2 plus 6, does that mean I get like natural log of 8? Is that what that means? Let's see, is Wilson there? I'm not hearing back from Wilson. What about Abigail? Abigail, would this be a natural log of 8?
No,
It's not. Okay, it's not. How come? You're right, by the way, but how come?
because natural log of 2 and 6 can't be combined.
They cannot be combined. Nice. Okay. My 6, that's not in a natural log. The 2 is in a natural log. They're totally separate. I have to treat it natural log of 2 separate from my plus 6. It's actually got to stay separate like that. All right. So there is my final answer. Okay. Do you guys have any questions on these so far? Nothing for reals. So these were exponentials. Let's see if we can move forward and look at logarithms. Let's see if we can solve some of the logarithms. All right, so Jess, do you know what I would start off with on number 3 here? Is Jess there? All right, not hearing from Jess. Let's see, Elliot, I'm gonna have you get me started then. Well, how would you start number 3? Ooh, the natural logs would cancel out. That is true. Like, basically, you're doing the same thing to both sides, right? Getting rid of the natural log on both sides. So let me clarify exactly why that means, exactly why that works. It works specifically because I can do e raised to this natural log and e raised to the other natural log. I did e raised to both sides, and then e's and natural logs, those are the inverses. That's why they're gone, but it's true. I got rid of the natural log on both sides, totally. So we're now down to 7x minus 4 equals a 2x plus 11. All right, so then let's see, Mayu, can you pick it up from here? Mayu, how would you solve for x?
I'd probably move the 2x to the 7x.
Okay, yeah, I would do that too. How do you move it over though?
Subtract the 2x.
Totally, that's what I would do also. Nice, so you got a 5x. Okay, then what do you do?
And then like move the -4 to the 11. So like add the 4 to the 11.
Okay. Nice, nice. Okay. Now what? I got one step left.
Divide by 5 using.
Divide by 5. Awesome. 15 divided by 5 was 3. Nice. Okay, so you know what we haven't actually done yet, which is a huge advantage for you guys? We haven't checked any of our answers. Like, you can, on your test, you can check and make sure you got it right. So let's see here. On number 1, if I'm checking my answer, I'm going to take this really messy. I'm going to take the blue one because I have a common log button in my calculator. I don't have a log base 7 button in my calculator. So I'm going to go with the blue answer here. It's just written in a different way. They're the same answer, but I'm going to go with this blue one, and I'm going to put it into my original problem here. All right, so this whole messy fraction is getting plugged in for this x. All right, so I'm going to get 7 raised to the 9 times x. And I'm going to replace the x with this really messy fraction. I'm replacing it with like a log of 15 divided by, and then in the parentheses, the 9 times log of 7. Okay, so yes, I put that whole messy thing in for the x, and let's see, if I did it right, this should equal what it says it's equal to a 15, right? Let's see if I got a 15. I did, yes, okay. So this messy answer is correct. All right. All right, so we're good on this. What about number 2 here? Let's check our answer for number 2. I'm going to take this, like I said, this messy natural log of 2 plus 6, and I'm going to plug that all in for my x in the calculator. All right, -2 times e raised to the, and I've got to put this in for x. I put my natural log of 2 plus 6. Oops. And the parentheses there. Natural log of the 2 plus 6. I gotta put that in for my x. And it said x minus 6. So I got all that stuff and then minus 6. And then at the very end, I had my plus 12 there. Let's see. If I did it right, it should say says it's equal to 8, right? So let's see if I got it right. Oh, yes, that also equals 8. All right, last one here, number 3, or sorry, the x equals 3. I'm going to plug that in. Natural log of 7 times x. I think my x is a 3, so like 7 times 3 minus 4. Let's see, that is really messy. Oh my goodness. So it's like 2.833, blah, blah, blah. That's when I plugged the x into the left side. Let's plug the x into the right side and see if it equals the same messy answer. So that right side was natural log of 2x, which I think my x is a 3, so like 2 times 3 plus 11. All right, let's see if it equaled the same thing. Okay, 2.83321. They both equaled the same incredibly messy decimal, but they're equal to each other. So as far as this equal sign, yeah, they are actually equal to each other. So check that one was correct as well. All right, so we checked our answers. Do you guys have any questions on these before I move on? Frills? No response. Should I be worried?
Maybe
Slightly.
slightly.
Bailey doesn't have a question. All right, thank you. We're good, Thomas. Jack's good. Thomas, we got it. Okay. Anybody have any questions? Any clarifications we need? Thanks for responding, you guys. Samantha's good. Crystal, no questions. Okay. Well, if you guys are good with these first three, I'm going to step it up a notch here. I'm going to go to number 4. And this is actually, Laura, this is what we were talking about at the beginning of class. Remember there was those log rules that we had to use to either expand or condense? I think because of this plus sign in the middle of my 2 separate logarithms, so that plus sign, I think I'm going to condense this down with multiplication. I need to multiply the arguments. I got to multiply my 5x times my x minus 1. So it's in a single log now, log of the 5x times x minus 1. Okay, do I have any questions on this whole condensing?
It's mostly getting rid of the other logarithm and combining it, but I can see that you're using the parentheses to kind of mash it together.
Okay, yeah, that's true.
So,
Mash it together, we like multiplied it together, right?
I don't like that.
Totally.
Have a parenthesis outside of another parenthesis. Like have the 5x.
Yeah, I've got like parentheses outside of parentheses like this.
Yeah.
That's true. Because I had to do the 5x times the entire x minus 1. That's why I had the parentheses around it.
Yep.
Totally. All right. I don't have any other questions on this before I move on. No questions. All right. Well, I'm going to pick it up from here then, and I'm going to turn this into exponential format, which I kind of went backwards up here. I went from exponential into logarithmic format. I'm going to go backwards. I'm going to go from logarithms into exponential. All right. So is Wilson there? Not hearing from Wilson. What about Thomas W? Thomas there? All right. Hey, Thomas. So, hey, Thomas, what is the base on this if they didn't write it? Nice. It's a base of 10. That is my common log. It's a log base 10. So that's got to be then the base on my exponential. I need 10 raised to some exponent. So Thomas, keep it going. What is the exponent? If I'm turning this into exponential form. So my question is about the exponent. If I'm going from a logarithmic form into exponential form, I have the base of my logarithm is now the base of my exponential raised to what exponent? Should we look up here? So not a 5 necessarily. So let's look up here. My exponent up here, the 9x, that actually was on the other side of the equation for my logarithm. Like the whole point of a logarithm is to solve for the exponent. right? So keeping that in mind, if the whole point of a logarithm is to solve for the exponent, what should my exponent be on this one?
10, so it's 5x times x minus 1 equals 10 squared.
Equals 10 squared. Yeah, oh, totally. So the exponent is that 2 right there. Like whatever's on the other side of the equation from my logarithm is the exponent. So this guy, the 2, was on the other side of the equation. So that's my exponent. And you said it equaled what again? So like, Thomas, what part have I not written yet? I took care of the base, that 10 that they didn't even write. We took care of the base. We took care of the 2. What have I not used yet? So Crystal, you're pretty close actually. It's actually this whole argument. It includes the x. So Crystal will include the x. It's just got to be that whole package deal there. You get what I'm saying? So like the whole 5x times x minus 1. Well, and I think I'm going to distribute. I'm going to simplify this down a little bit. 5x times x is a 5x squared. And then I've got my 5x times negative 1, so a negative 5x. All right, Thomas, you doing okay with this? All right. All right, so nice, Crystal. We've got this in exponential format now. Now, if I'm trying to solve this, okay, here's what I'm thinking in my head. I'm thinking, all right, I got to solve for x, but small problem, I've got an x squared and then a plain x, like I can't combine them. They're not like terms, which if I have 2 separate x's, that usually means that I need to like have this all equal to 0 and factor it. That's usually what I do when I have an x squared and an x. So I think what I'm going to do is, let's see, 10 squared, 10 times 10 is 100, right? I think I'm going to subtract 100 on both sides because I want it equal to 0. If I'm going to have to factor, I want to be able to set my factors equal to 0. All right, and then let's see here. If I was going to factor, again, this is kind of my thought process. I'm like, man, that looks like a royal pain in the butt. Look at all those like pretty big numbers there. I think what I would do is divide them all by 5. Like 0 divided by 5 is still 0. 5 divided by 5 is 1. So I get like 1x squared and a negative 1x. And let's see, 100 divided by 5 is 20. All right. So my goal is to, eventually I want to factor this and set my factors equal to 0. All right, looks like this kicked us out for a sec. Let's see if we can get this working. All right, so working now. All right, there we go. All right, so I'm going to factor this, which, let's see here, Jacob, you already factored this one, right? What were your factors on this again?
I got 4 and negative 5.
So x plus 4, you got your positive 4 and your negative 5 like that? Nice. Okay, so 4 times negative 5, they multiply to be my negative 20, and 4 plus negative 5, they add up to my negative 1 right here. All right, looks good. Now, that doesn't mean x equals a positive 4. I'm actually going to change the signs on here. X equals a negative 4, because I want this all to equal 0. So like negative 4 plus 4 is 0. All right, and then I'm going to do the same thing with my negative 5. I'm going to change that sign to a positive 5, because again, 5 minus 5 is 0, and I wanted it to all equal 0. Okay, when I see this in my head, I'm going, there's a big alarm going off in my head. I got 2 answers, and I'm supposed to check for an extraneous solution. So in my mind, I'm going, uh-oh, one of these is probably like an extra, like an extraneous solution. I need to check these out and see which ones work, which ones don't. All right, so here's what I'm gonna do in my calculator. I'm gonna check both of these guys in the original problem. So let's try the negative 5. Log of 5 times x. I'm trying to -4. I'm putting a -4 in for my x. Plus log of, and then -4 minus 1. And then, oh, error. What's up with the error on this? Huh. So obviously plugging the -4 in didn't work. Do you guys remember why? Do you guys know why that didn't work? Yeah. Oh, log of a negative? Like 5 times -4 is a -20. I can't do log of -20, right? All right, so just to clarify, let's refresh our memories of the graph. Yeah, it's the negative, Jack. So let's brush up on this real quick with the graph. My logarithm graph usually looks like this, right? Where there's an asymptote on the y-axis. Asymptote is something it gets really, really, really close to, but it does not cross. So it actually doesn't go over here into the negative x's at all. I can plug in a bunch of positive x's, but negative x's, I can't do the log of a negative x. So for that reason, this was my extraneous solution. That's out. The +5 should work again. I can plug in positive numbers. Let's check this out though. I'm gonna put this in my calculator. So I'm gonna test my +5. So log of 5 times 5 plus log of 5 minus 1 instead of the -4 minus 1. All right. Okay, that gave me my nice pretty whole number 2, which actually this was supposed to equal a 2, so that's a good sign. The 5 worked. Okay, so I had one answer. X equals a 5. Okay, any questions? For reals, you guys are good on all these? Even like the green, like the log rule that I had to condense it with, all that good stuff. You guys are okay with all this stuff? Yes.
What part of the equation did you graph off of, or like do the basic example?
Oh, thanks, guys. So my graph, your question is about the graph?
Yeah, what is that?
So this was just kind of like a basic log function. Sometimes they're a bit longer, sometimes they're a bit like shorter like this, but they kind of have that same basic shape where it curves, it gets really close to the y-axis, like to 0. It doesn't cross it though. So that's kind of my just basic shape of a log graph. Does that kind of clarify it all? Okay. All right, so yeah, I wasn't very precise about it. This is just like any log. All right, guys, thanks for letting me know we're good. If you guys are good on this, we're kind of running out of time a bit, so I'm gonna move on to 7 and 8. If we have some extra time, I'll go back to the other ones, but inequalities. Let's see if we can solve some inequalities. All right, so number 7 is an exponential inequality, and then number 8's got a logarithm. They're kind of like opposites, you know? Let's see here. My number 7, I'm gonna do whatever's the opposite of e to the x. Tyler, how do I get rid of that e in my e to the x? So I'm asking you about number 7. I'm trying to get the x by itself. So how do I get rid of that e? How do I get rid of the e and get that x by itself? So I actually need to do the opposite of an exponent. I already have the exponential form.
Yeah, so you use the log. So
I do need a log, yeah. What kind of log? Natural log. Nice. How'd you go with the natural log? Oh, the base of e. So natural log is a log base e. So you're basically going to do a natural log on both sides. And then natural log of e to the x, like the natural log and the e kind of are inverses. They undo each other. All I'm left with is the x. All right, so it says though, it says x is greater than or equal to natural log of 5. Let's, I'm gonna check my answer here. So in my calculator, natural log of 5 is a really messy decimal, but whatever, it's like 1.609, blah, blah, blah. All right, so let's test stuff that's bigger than the 1.609. I mean, you could test something like really close to it. I could test like a 2. That's bigger than it. That's bigger than this decimal. I could test it, like I said, a 2. I could test a 100, whatever. I can test stuff that's bigger than that natural log of 5. And here's how I test it. I then plug that number into my original. I'm not plugging it into my answer. I'm plugging it into the original problem. And I'm trying to see if this actually works. If the e raised to that exponent, so in my case, I'm testing a 2. So does e raised to the power of 2, is that going to be actually greater than or equal to 5? All right, that got me a 7.3, yada, yada. That's greater than or equal to 5. That works. Even if you guys chose like a way bigger number. So yeah, if I chose like my 100. Wow, it's so huge, they had to put it in scientific notation. Look at that. The E43, that they like moved the decimal over like 43 times. It's a huge number. Definitely greater than or equal to 5. So it didn't matter, as long as I picked anything on this side of my natural log of 5, it was all true. These are my answers, that's correct. So here we go, there's my final answer. All right, so this one was exponential, and you did the opposite of exponential. You used a logarithm to solve it. Number 8 here, this one is in logarithmic form, so I'm probably at some point going to have to do the exact opposite of that. I'm going to have to do exponential form to solve this one. All right, but I need to get this log of x by itself first. So Tabitha, I'm going to come your way. How do I get that log x by itself? Is Tabitha there? Nice. Okay, so divide by the -2. And you know what? I am going to have to do that at some point. I personally don't think that would be my first thing, because I would have to divide all of this stuff by -2. I think I'd rather get rid of the 6 first. So yeah. So Tabitha, I am going to do that. And Evan, I'm going to do what you were saying. I'm going to subtract the 6 on both sides first. And then, okay, then Tabitha, now I'll divide by the -2. Okay, there's like a big alarm going off in my head. Dividing by a -2? What does that do to my inequality? Do you remember? Oh, it flips the sign. So this inequality, whenever I either multiply or divide by a negative, whoop, facing the opposite direction. Nice. Okay, so I did get the log x by itself, though. That was kind of my first thing I had to do, get the log x by itself. Second thing I gotta do is I need to get rid of this log. Like I need to put it in exponential format here. All right, so let's see here. Lauren, what's the base? If I didn't write it, what's the base on this? Is Lauren there? All right, Lauren. Nice. What's the base if they didn't write it? So similar, let me look up here real quick. That was like That was like these guys. See how they didn't write the base on that? Yeah, you got it. So then when I put it in exponential format, what did I make my base on this, Lauren? Totally 10. Every time they don't write the base, it's that common log base 10 every time. So I'm gonna have to do a base of 10 raised to each side. Like I'm doing 10 raised to a log x, and I'm doing 10 raised to a -1. I'm doing 10 raised to each side. And the whole point is because log base 10, exponential base 10, those are inverses. Bam, undo each other, gone. What about that negative exponent? Let's see here. Jorge, what does the 10 to the -1? Jorge, what does that end up as? Is Jorge there? All right, we're gonna have to, let's see. Bailey, I'll reach out to you, Bailey. What does 10 to the -1 look like if I simplify it down? Nice, Bailey. 1/10. It's like 1/10 to a +1, like my 1/10 there. Perfect. Okay, so it looks like this is my answer. Let's check this out. On my number line, I'm gonna check my answer. Here's my messy 1/10 here. Let's pick something bigger, something smaller. Let's kind of check both sides of my 1/10 here. So if I pick something bigger, I don't know, maybe I'll pick like a 5. Sure, whatever. So Evan, pick something less than 1/10. Anything.
1/30.
1/30. Nice. 1/30. So that's like a positive number that's less than 1/10. Do you guys want to pick a negative number? Jacob, pick a negative number. -2? All right. All right, so I'm actually going to use all these. I'm going to check it out, make sure this is working. And I'm going to check this 5. I'm going to put it into my original problem up here. So the original problem said -2 times log of, and I'm testing a 5, right? -2 times log of 5 plus 6. And if I did this right, it should be less than or equal to 8. All right, 4.6, blah, blah, blah. That's less than or equal to 8. So that part works. All right, this side, that works. Let's try my 1/30. All right, -2 times log of 1/30. And then the plus 6 there. If I did this right, it should be less than 8. No, that is greater than 8. 8.95, yeah, that's greater than 8. So this part was out. Now, I just wanted to play with the -2 real quick. All right, -2 log of -2 plus 6. Oh, there was an error on this. I did not get an error on my 1/30, but I did get an error on my -2. So, I mean, that tells me both of them don't work, but they gave me like different kind of thing going on in the calculator. So my answer is still, yeah, this part that worked was greater than or equal to the 1/10. That's true. But what if they wanted me to be, let me change this for a sec. What if they said greater than or equal to? What if they put it like this? Like I'd still subtract the 6 over. I would still divide by -2 on both sides. Okay, which means dividing by a negative makes me swap the inequality. All right, I still would turn it into exponential format. Okay, so this is what I would get. It's just the inequality is facing the other way, right? which on my number line, here's my 1/10. If I wanted less than or equal to, then this stuff to the left, those are less than, those are smaller numbers, right? But this stuff over here would not work. Those would be greater than. But I think it's not going to work out the exact same. So here's what I mean. -2 times log of my 5. I actually did that already. -2 log of 5 and then plus x. That was like a 4.6 yada yada. If I want it to be greater than 8, 4.6, that's not greater than 8. That part would be out, right? My 1/30. Let's see, this 1/30, when I plug that in, I got an 8.95, blah, blah, blah. That is greater than 8. So that makes this true. So that part would work at the 130. But the -2, when I plugged in the -2, I got this error. So like at the -2, that part would not work. So I'd have to have like a cutoff here somewhere. I would have to have like a middle section that actually works. Where would I have to cut that off? Think about it for a sec here. If I was trying to be on this side, x is less than or equal to 1/10. Where do I cut it off? And so I stop getting those errors in my calculator. See this little error here? Oh, come on, guys. Do you know what the deal is? Where would I cut this off? Look at your graph. Let's look at the graph over here. I had an asymptote somewhere because my logarithm didn't even exist. It didn't even exist over on that left side. So what's my cutoff? Again, I'm looking at like an x-axis. What x value cut off where the graph exists and where it doesn't? Come on, what is this x number here? What's that x value? Alani, I'm going to come your way then. Alani, what is this x value that chops off from where my graph actually exists to where the graph does not exist? What x value is that? 0. Yeah, you're right. It's an x value of 0. It's like between, these are all positives over here, and then you got like negatives on the left side. So between the positives and negatives is 0. Totally. So at the x value of 0, that kind of chopped it off into like nothing exists over here. So on my number line that we were looking at right here, if they did want me to be like x is less than or equal to 1/10, if they wanted that, I would have to say less than or equal to 1/10, but still greater than 0. Do you guys remember doing this yesterday? I actually would have to put it between 0 and 1/10. Because I had to chop off all that negatives. Those were not my domain. Okay, so the original problem said x's are greater than or equal to. I didn't have to chop that off at 0. 0 is down here, so that didn't really mess with it at all. It's just if they made me go less than or equal to the 1/10, I would have to chop that off at the 0. I have to consider the domain of this function. All right, and I asked this question like 5 times, and I had to call on somebody to get an answer of any kind. Do you guys have any questions on this? It seems like we're not entirely confident right now. Come on, let me have what questions you guys got. No questions. All right, then here's what I want to know. You guys give me a number 1 through, oh wait, did I get a question? I got a question. Hallelujah, Jack, I got a question. All right, it'll be always cut off at 0. Okay, so Jack, that is a great observation. I keep cutting it off at 0 because it's a plain x in my logarithm. If they had like a horizontal shift, like if I shifted the entire graph, you know, left by 2 or something like that, if I shifted over here, then it would get cut off at -2 instead of 0. So you would have to pay attention to any horizontal shifts. Does that make any sense? Okay, nice, Jack. Thanks for asking the question. Anything else? No, so you guys can do this on your own. All right, here's my question for you guys then. I need a 1 through 5. On these inequality ones, either exponential or logarithms, any of the inequalities, I want to know a 1 through 5. 1, I don't know where to start. 5, I can do it on my own, no problem. Maybe somewhere in the middle there. Let me know. Where are we at? 1 through 5. In the classroom, I need to see your fingers. 1 through 5, where are we at?